April 26, 1986. Just past 1:23 a.m., Reactor 4 of the Chernobyl nuclear power plant exploded. What was supposed to be a routine safety test turned into the worst nuclear disaster in history. A botched reactor shutdown sequence caused a massive power surge, rupturing fuel rods and igniting the core. The explosion blew off the reactor's 2,000-ton steel lid and launched a fireball of radioactive debris into the atmosphere. The graphite moderator caught fire, spewing radiation 400 times more powerful than the Hiroshima bomb. Within hours, the sky above Pripyat glowed with an eerie blue light, and the air itself became poisonous. But the visible destruction was only the beginning. As firefighters and plant workers were trying to contain the blaze, a deeper, hidden problem was forming inside the ruined reactor. The core didn't just explode, it melted. Nuclear fuel, steel, graphite, and control rods fused into a radioactive lava, eating through the reactor's floor like acid. It oozed into lower levels of the building, eventually forming grotesque, solid masses. One of these would become infamous, a twisted, steaming shape with a cracked, wrinkled surface. Black, glossy, and impossibly radioactive. They called it the elephant's foot. Around December of 1986, a full 8 months after the disaster, staff at the site reasoned that it was time to assess the damage underneath the reactor. Radiation levels remained lethal in many parts of the facility, especially where molten fuel had pooled and cooled. At first, robots were sent in to assess the damage, but failed. Circuits fried, cameras blinded. The radiation levels were just too much for the equipment available. If they were to understand the threat, someone had to go in on foot. Cue Arthur Korniev. Arthur was a Soviet radiation specialist and inspector. He was among the first to be sent into the reactor's lower levels. His task was simple on paper: assess the damage, locate the remaining nuclear fuel, and document anything dangerous. In reality, it was a suicide mission. Though 8 months had passed, radiation levels were still high. First readings peaked at 10,000 Roentgens per hour, an unmanageably high dose of radiation. For comparison, a full-body CT scan gives you about 1 Roentgens. A dose of 500 is generally fatal to humans within weeks. At 10,000 Roentgens per hour, a person standing near the elephant's foot in 1986 would receive a fatal dose in less than 60 seconds. Arthur entered the maintenance corridors with only basic protection: a lead apron, a dosimeter, and a camera. Every step was a countdown. Each second spent inside chipped away at his lifespan. He found the elephant's foot in a hallway now known as Steam Distribution Corridor 217/2. A black, glassy mass that looked like the cracked skin of an elephant. It wasn't moving, but it was still radiating death. The first photos were taken by him. Some now iconic, blurry, ghost-like, warped by radiation. But they needed more than just photos. They needed a sample. Scientists needed to analyze the elephant's foot to understand its chemical structure, what was its composition, and whether it posed an ongoing threat. Problem was, getting too close to it wasn't an option. It was simply too dangerous to be near it. So they shot it. Firing a bullet into a lump of nuclear waste sounds like something out of science fiction, but at Chernobyl, it was necessity. A modified AK-47 rifle was brought in. From the safety of a shielded corridor, a soldier fired an armor-piercing round into the mass. The rifle shot, worked, the brittle surface cracked, and a fragment fell to the floor. A bullet had done what machines and men could not. It wasn't just a workaround, it was survival through improvisation. This sample collected from the elephant's foot helped scientists understand exactly what they were dealing with. It confirmed the mass was not just radioactive fuel, but a new synthetic material. Corium. When the reactor core at Chernobyl overheated, temperatures exceeded 2000 degrees Celsius. At that point, the fuel rods, made of uranium dioxide, melted. The cladding around them, typically zirconium alloy, also liquefied. As the containment structure failed, this molten fuel mixed with everything it touched: graphite moderators, steel, concrete, and sand. The result was corium, a lava-like substance, black, glassy, and dense. It flowed through the plant's lower levels before solidifying into bizarre alien shapes, including the elephant's foot. It's a man-made nightmare, a molten mass of nuclear fuel and reactor materials formed during a full meltdown. It is radioactive because it contains fission products and transuranic elements, isotopes like cesium-137, strontium-90, iodine-131, and plutonium-239. These are byproducts of nuclear fission, and many have half-lives ranging from decades to thousands of years. Though corium stems from nuclear meltdowns, no two formations are identical. Each is a unique snapshot of failure, shaped by the materials in the reactor, the speed of the meltdown, and the chaos of the event itself. Knowing its composition allowed engineers to model how it would behave, how fast it would cool, whether it would still melt further, and how long it would remain a threat. It also proved something else. The meltdown had released most of the reactor's fuel. What was left behind was largely immobilized, dangerous but no longer active. That fragment bought time and insight. Arthur Korniev would become one of the most heavily exposed survivors of the Chernobyl disaster. Over the course of multiple missions into Reactor 4's lower levels, he absorbed radiation doses that far exceeded safe limits. He suffered from partial blindness, cataracts, and other long-term radiation-related illnesses. Yet, despite it all, he continued his work. In later years, Arthur supervised inspections of the decaying sarcophagus and helped plan the construction of the new containment structure. His pragmatism became legend among his peers. He once joked that being so radioactive himself made him the perfect man for the job. Arthur lived well beyond initial expectations, a testament to both luck and resilience. His haunting photographs of the elephant's foot remain a stark reminder of the human cost behind the world's worst nuclear disaster. Today, the elephant's foot still exists in the ruins of Reactor 4. It cooled and no longer glows or steams, and thanks to radioactive decay, its emissions have dropped drastically, but it remains a monument to catastrophe. The elephant's foot is no longer lethal on contact, but it will remain radioactive for centuries, a relic of what happens when human error meets unstoppable energy.